Okay, welcome to Calculus Day 1 of Lesson 1.3 on continuity. It's going to be a short day today because you had a quiz earlier, and so we'll just make it through the first half of the notes. So starting right off, let's look at some graphs. I'm going to talk about them one at a time, so I'm going to zoom in on A. So we have a graph, and it has a point right here at CF of C. And so if we look at the limit coming from the left and we look at the limit coming from the right, those are equal. And let's just say this is F of C, right? The Y. Then they both are going to F of C, so they equal F of C. But F of C also equals F of C. So let's put a number in here. So that could be 2. So, and let's make this 1. So we can say, if we're putting numbers in, the limit as x goes to 1 of f of x from the left is equal to the limit as x goes to 1 from the right of f of x. And that is equal to, and they're both equal to, 2. And then we also see that f of 1, where I was taking the limit of, right? F of 1 is 2. So that's why you have that the limit on the left equals the limit on the right, and they're equal to what the point is at that point. Now here's an example would be. We have the limit on the left. That's going to equal, let's just call that, f of c. And the limit on the right is equal to f of c. Well, I guess we can't call it f of c right now because it's going to be different than what f of c, because there's a dot right here. Okay, so let's just call that, I'm going to erase. Let's just call that b. So the limit of f of x from the left is equal to the limit of f of x from the right, and those are both equal to b, but it's not equal to what the function is at c. So the limit from the left at c is equal to the limit of the right at c, but those aren't equal to f of c, because f of c is down here at a. Okay, so that's the third one I want you to be aware of. Now here, we have the limit from the left equaling the limit from the right. So we'll call that b. The limit as x goes to c from the left is b, and from the right is b, and so they're equal. But f of c is not defined. There's no dot. There's no dot at c. Okay, so just take that. So that's not, okay, I should go back. When we had all these true, that was continuous, right? I mean, you can look at the graph. We can tell this graph is not continuous. It's not continuous. It has removable discontinuity. This one right here is not continuous. Say, same thing as a whole. And now let's look at this one. D, the limit from the left is not equal to the limit from the right. So we have the limit as x approaches c not equal to the limit as x approaches c from the right. But f of c is defined. But still not continuous. So we're trying to get you to see this relationship. Okay? And the last one, we have the limit not equaling from the left, doesn't equal to the right, and f of c doesn't exist. Okay, So we're talking about continuity here. And only one of these situations had a continuous function. And that was when the limit existed, the limit from the left was equal to the limit from the right. So the limit existed, and it was also equal to, well, it didn't just exist, the f of c existed also. So the limit existed, f of c existed, and they were equal to each other. Not equal to each other, they were equal to each other. Okay? They were equal to each other. So that helps us write the definition of continuity. It has 3 parts. Okay, so the first part is the limit as x approaches c of f of c. I'm not f of c, f of x exists, which you know means that the limit as x approaches c from the left of f of x is equal to the limit as x approaches c to the right of f of x, from the right of f of x. So you know that's what makes a limit exist. So first of all, the limit has to exist for a function to be continuous. Second of all, the function has to be defined at c. So there's a dot, right? Okay, there's a dot. You know what I mean. F of c exists. Okay, it's defined. And the last thing that has to be true, if you went back and looked, what was true? They were all equal to each other. Okay? So, to write it out, you would say the limit as x approaches c of f of x is equal to f of c. So this has to be the same number. The limit has to equal what the function is at the limit. So say it again. The limit has to equal what? The limit at c has to equal what the function is at c. Okay, so that's the definition of continuity. It's got 3 parts, and all 3 parts you have to say are true for something to be continuous, for a function to be continuous. 3 things. Once more, the limit exists at the point you're talking about. The function exists at the point you're talking about. And the limit and the function are the same at that point. Okay, so I'll stop the video here and we'll go on to the next one.